Hello, my name is Mark Pinkerton and I'm a Senior Account Manager here at Fluid Life, and today we're going to be talking about diesel fuel, quality, and cleanliness. Let's start off by running through a quick summary of our talking points for today. So we'll have an intro to diesel fuel, what is a diesel fuel, stuff like that, diesel fuel quality, characteristics, cleanliness and contamination, mitigation and control strategies for that contamination. And finally, we'll end off by talking about how you can monitor diesel fuel quality and contamination and cleanliness through diesel fuel lab analysis. Introduction to diesel fuel. Diesel fuel is a liquid fuel designed specifically for use in a diesel engine. Ignition or combustion of the diesel fuel is the primary power source for a diesel engine. Diesel fuel is atomized and mixed with air in the combustion chamber. Pressure caused by a piston rising results in a rapid increase in temperature. When fuel is injected, the fuel and air mixture ignites, releasing the fuel energy, forcing the piston downward, and turning the engine crankshaft. The difference between diesel fuel and other fuel types like gasoline is diesel fuel engines do not require a spark. The ignition comes from the rapid increase in temperature from compression. Aside from being the primary combustion energy source of a diesel engine, diesel fuel also acts as a coolant and lubricant for the fuel system components like injectors, pumps, valves, etc. Its job is to dissipate heat, reduce friction between surfaces under load, and provide lubrication to moving fuel system components. There are three different grades of diesel fuel based on viscosity, thickness or resistance to flow, pour point, temperature of flow, and combustion quality. Number 1 diesel has the lowest viscosity and is typically used in colder climates. Number 2 diesel is the most common grade and used in warmer climates and during the summer in colder regions. And number 4 diesel, which is somewhat uncommon for typical application and used more in lower speed engines. Diesel engines are typically much more fuel efficient than gas engines, even those with very high compression ratios. Diesel fuel is also more energy dense than gasoline, meaning more energy per gallon overall. Traditional distillate diesel fuel is the most common type of diesel fuel and is created from the fractional distillation of crude oil. Hot oil is pumped into a distillation column where different petroleum products separate for collection. The lightest hydrocarbons present, usually things like propane and butane, rise to the top. Since gasoline is a little heavier, it doesn't rise quite so high and is drawn off from the side of the column. Kerosene and diesel, the next heavier products, are drawn off at lower points on the column. Biodiesel is a type of diesel fuel that is created through the conversion of feedstock into fatty acid methyl esters, or FAME. Feedstock can be various things like soybean oil, cooking oil, animal fats, etc. The conversion process is called transesterification, where an organic fat or oil reacts with an alcohol to form esters and glycerol. There are some advantages and disadvantages to consider when comparing biodiesel fuels to more common diesel fuel types like the ones produced through crude oil distillation. The advantages of biodiesel fuels are closely related to environmental factors. Biodiesels also offer better natural lubrication for your engine's fuel system components. However, the main disadvantage of biodiesel fuel is the reduced fuel economy from less overall stored energy, less power per liter or gallon. Other disadvantages are tied mostly to biodiesel's susceptibility to degradation and the creation of byproducts, microbial growth, and insolubles, all of which we'll talk about more later in this presentation. So, a couple other less common types of diesel fuel. Synthetic diesel, which is produced when carbon materials are gasified and then converted to diesel by the Fischer-Tropsch process after purification. Hydrogenated oils and fats, produced by converting triglycerides into alkanes through hydrogenation. This diesel fuel type is different from typical biodiesels as FAME-based biodiesels use transesterification instead of hydrogenation. And finally, dimethyl ether, or DME, which is a more gaseous diesel resulting in cleaner combustion and higher energy output, but typically requires modifications to a diesel engine for use. It's common for diesel fuel suppliers to blend diesel fuels. The blends provided are typically based on ambient temperatures, seasonality, and the geographical area of operation. Summer diesel fuel blends have a high concentration of number 2 diesel, if not all number 2 diesel, while winter diesel blends are usually a mix of number 1 and number 2 diesels. Remember, number 1 diesels are thinner than number 2s to maintain flow and to ensure proper combustion in colder temperatures. It's also common for diesel fuels to have a combination of traditional distillate-based diesel and biodiesel. When looking at your diesel fuel specifications, the amount of biodiesel in your diesel fuel is defined by the BX value. Individual engine OEMs will have maximum BX value recommendations that should be followed for proper engine operation. Section 2. Diesel quality and characteristics. Diesel fuel quality is defined by a number of characteristics that detail and measure its combustion efficiency, emissions, flow, etc. The first one we'll talk about is a fuel cetane number. The cetane number is a measurement of the combustion quality of a diesel fuel. It's an indicator of the combustion speed and compression required for ignition. The higher the number, the better the fuel burns in an engine, just like octane ratings for gasolines. Higher cetane number fuels are desired in colder temperatures. Diesel fuels with too high of a cetane number can bring unwanted issues such as increased torque peak smoke. Most OEMs recommend a diesel fuel with cetane number no lower than 40. You may also see cetane index instead of cetane number. Cetane index is simply a more practical substitute for cetane number in terms of diesel fuel testing, as cetane number requires a special engine to produce a valid result. The cetane index instead uses the density of the fuel along with fuel distillation recovery temperatures to estimate the cetane number. These estimations represent the natural cetane number of a fuel and are not affected by cetane number improvers, which are additives to improve ignition that might be present in a diesel fuel. Distillation. We mentioned this on the previous cetane index slide. We basically boil a fuel sample at increasing temperatures and measure the amount of vaporized fuel at different points. Aside from being used in cetane index calculations, fuel distillation is useful to determine if a fuel is a summer or winter blend and can also help in identifying potential gasoline contamination in your diesel fuel. Fuel volatility, which represents the ease of a fuel's vaporization, is directly related to fuel distillation. An important value related to fuel distillation is the T90 value, which is the temperature at which 90% of the fuel has evaporated during the boiling process. Fuels with too high of a T90 value may cause an increase in engine smoke, deposits, soot, and particulate emissions, while fuels with too low of a T90 value may cause cavitation of the fuel pumps and other fuel system components due to evaporation at lower temperatures. Density and API gravity. The density of a fuel is a good indicator of that fuel's power output during combustion. API gravity is a common metric tied to fuel density. Fuel density and API gravity are inversely related to each other based on the API formula. Diesel fuels with higher densities, or lower API gravity values, will produce more power than those with lower densities or higher API values. Higher API gravity values typically lead to increased fuel consumption. We've established that diesel fuel is more than just a power source for the engine. It also serves as a lubricant for fuel system components. This lubrication is directly related to a fuel's viscosity, which is a measurement of a fuel's resistance to flow. Like other diesel fuel characteristics, OEMs have maximum and minimum viscosity requirements depending on your fuel blend. Improper fuel viscosity can lead to a number of potential engine problems, including a reduction in combustion from poor spray patterns, wearing of fuel pumps and injectors, leakages, and poor system flow and filter clogging. Diesel fuel lubricity represents a fuel's ability to reduce friction between two surfaces under load. Lubrication provided by the fuel is needed to prevent wear or seizure of fuel system components. When temperatures drop, wax crystals will start to separate out from the diesel fuel. The cloud point is the temperature at which this starts to occur, giving the diesel fuel a cloudy appearance. It's common for fuel suppliers to add pour point depressants, an additive that reduces the cloud point of a diesel fuel to prevent wax from separating out, especially for winter diesel blends. Most engine OEMs recommend using a fuel with the cloud point being 6 degrees Celsius lower than the coldest operating temperature. We'll see later how this wax can cause fuel flow and filter clogging issues. The flash point of a fuel is the lowest temperature at which the fuel gives off enough vapor to ignite. This represents one of the main differences between diesel fuel and gasoline. Diesel fuel being a combustible fuel, which requires a higher than ambient temperature to ignite, compared to gasoline, a flammable liquid that gives off enough vapors for ignition at normal working temperatures. Sulfur occurs naturally in crude oils and subsequently in crude oil distillate diesel fuels. Sulfur, along with other impurities, are removed from the diesel fuel after the refining process. This is because after combustion in an engine, the sulfur in fuel forms particulates that are a primary contributor to air pollution and the cause of harmful corrosion in the engine. Today, everyone is required to use ultra-low sulfur diesel, or ULSD, which contains less than 15 parts per million of sulfur. While ULSDs reduce the amount of air pollution and potential engine corrosion from diesel fuel combustion, they also have some challenges related to important fuel characteristics. First off, lubricity, the fuel's ability to be a lubricant. Reducing the sulfur content reduces a fuel's natural lubricity, increasing the potential for wear on fuel system components. Cold flow. ULSDs have poor cold flow characteristics from a reduction in aromatic content during the refining process. This causes ULSD fuels to have higher natural cold filter plug points. And finally, hygroscopic fuel. ULSDs naturally absorb and retain more water. Water in diesel fuel, which we'll talk about more later on, can cause rust, corrosion, promote microbial growth, and reduce overall fuel flow. Ash content. This represents the amount of inorganic impurities in the fuel, typically silicone, nickel, aluminum, iron, etc. The combustion of higher ash content fuels leads to increased pollution from engine emissions. These emissions can be harmful to the engine itself and exhaust treatment systems. Ash impurities are present in a diesel fuel as leftovers from the refining and purification process or as additives. Copper corrosion, a measurement of a diesel fuel's tendency to corrode by its reaction with copper, brass, and/or bronze parts of the fuel system components. Most engine OEMs require a copper corrosion index value of no higher than 3. The lower the better, however. Carbon residue. This measures the tendency of a diesel fuel to create carbon deposits after it's burned. When a diesel fuel doesn't fully burn due to a high carbon-hydrogen ratio, there is a better chance that you will start to accumulate deposits on intake valves, pistons, exhaust components, etc. This isn't the only reason for potential buildups, however. The carbon residue characteristics of a diesel fuel are highly dependent on the refining process of the fuel manufacturer. Diesel fuel additives. Just like lubricants, diesel fuels also contain additives to aid performance. Fuel manufacturers and suppliers will use additives to improve or modify certain fuel characteristics like lubricity, cloud point, etc. From an end user perspective, Fluid Life doesn't promote the use of aftermarket fuel additives on a general basis. Improper use of additives can lead to things like deposits, component seizure, corrosion, plug filters, etc. It's best to always consult with your engine OEM and/or fuel supplier before using any aftermarket additive. All of the fuel quality characteristics we just reviewed are a part of ASTM D975, which is known as the Standard for Diesel Fuel Specifications. This outlines various acceptable maximums, minimums, and expected values for different diesel fuel characteristics to ensure proper combustion, engine health, and reduce environmental impact related to diesel fuel consumption. While many different engine OEMs have their own diesel fuel specifications and guidelines, many of their requirements are based on the ASTM D975 specifications. Here's a quick snapshot of the D975 specifications for number 1, number 2, and number 4 diesel fuels. The full D975 standard outlines specifications for 7 grades of diesel fuel in total. More details about D975 are easily found on the internet as needed. Diesel fuel cleanliness and contamination. Today's modern diesel engines have higher pressures and smaller clearances for fuel system components compared to diesel engines of the past. As such, it's very important to use clean diesel fuel to ensure engine performance, engine reliability, and to achieve total expected engine life. Engine issues related to diesel fuel quality and cleanliness are typically related to water in the fuel, solid particulate contamination, fuel degradation and oxidation, filter clogging, and carbon deposits. All diesel fuels contain some amount of water. However, we want to keep the total concentration of water as low as possible in our diesel fuels. There are 3 different stages of water contamination in your diesel fuel depending on the amount of water present. Dissolved water. Water is present in the fuel, but in solution. This concentration of water will typically not cause any issues to your engine. The warmer a diesel fuel is, the more water it can hold as dissolved water. Emulsified water. This is the point where the water concentration is too high and the water can no longer be held in solution completely. This is also known as the saturation point. At this stage, fine water droplets start to appear and remain suspended in the fuel for the most part. Free and dispersed water. The water concentration is high enough where the water droplets are too big to remain in suspension and now settle at the bottom of the tank. Water in diesel fuel becomes an issue when the saturation point is reached, meaning there are water droplets in suspension. A good general guideline to follow for maximum water concentration in your diesel fuel is 500 parts per million, or 0.05%. That being said, different diesel fuel types at different temperatures can have very different saturation points. Water can contaminate your diesel fuel during delivery, while in storage, or while in use in your equipment. The most common sources of water contamination in your diesel fuel are wet diesel from your supplier, where your fuel supplier provides fuel with water already in it, condensation within your tanks from humidity and tank breathing, tank contamination from things like rainwater, power washing, etc., and handling and dispensing errors from things like damaged vents, fill ports, seals, etc. Issues from water in your diesel fuel start to arise when the concentration of water is high enough to cause emulsified and free water, beyond the saturation point, essentially. Emulsified and free water in your diesel can lead to fuel system components corrosion, reduced lubrication from the diesel fuel, and pitting, cavitation, and spalling from free water flowing through the fuel system. Corrosion. Water increases fuel degradation by combining with acids naturally present in the fuel to corrode fuel system parts. Water promotes the creation of sulfuric acids in the diesel fuel that chemically erode metal surfaces. Accumulation of rust can lead to component seizure. Injectors can also fail quickly from rapid corrosion. Fuel lubrication. Again, fuel acts as a lubricant for fuel system components. Water can break down the protective film strength of the fuel and lead to increased metal-to-metal contact of low-clearance fuel system parts. This leads to increased abrasion wear. Free water in the system. Surface fatigue and erosion caused by the interaction of free water with fuel system pressures and temperatures. The three main types of wear are pitting, caused by free water flashing off on hot metal surfaces of fuel system components. Cavitation, vapor bubbles from free water evaporation implode when subjected to sudden extreme pressures. And spalling, free water is forced into microscopic cracks present in metal surfaces. High pressures cause water to separate at the molecular level and release hydrogen in small explosions. Water in diesel fuel can also have negative effects while in storage. The presence of water in your storage tanks promote microbial growth, which increases the amount of solids in your fuel, along with increasing the potential for clogged filters, rust and corrosion in your storage tanks, chemical reactions with your fuel additives, and fuel oxidation, which increases the amount of acidic compounds and diesel fuel byproducts. Solid particulate in your diesel fuel is another major cleanliness issue to always keep top of mind. Today's common rail injection systems can exceed pressures of 30,000 psi and can have clearances as low as 2 to 5 microns. Most engines are designed to handle particulate in diesel fuel up to 4 microns in size only. The higher the amount of total solids and the largest size of debris present on average in your fuel will have a big impact on overall engine health. Solid particulate contamination in your diesel fuel leads to increased surface wear of fuel system components, especially for your injectors. Solid particles traveling at high speeds will gradually erode metal surfaces and create flow lines, which in turn can lead to fuel leakage. Particles can also embed themselves into sealing surfaces, impacting the overall useful life of your injectors. Even particles as small as 4 microns can cause unwanted erosion of fuel system components over time and reduce the expected life of parts or the engine itself. The cleaner your diesel fuel is, the better. Like water, solids can contaminate your diesel fuel from delivery, while in storage, or while in use in your equipment. Some common sources to always consider when thinking about solid particulate contamination of your diesel fuel are dirty fuel from your supplier, when your fuel shows up dirty already, corrosion and rust from your storage tanks, microbial growth in tanks that act like solids and can clog filters, general contamination from external sources, breakdown of fuel system components like fuel lines, seals, gaskets, etc., and handling and dispensing errors. To minimize the negative impacts of solid contaminants in your diesel fuel, your ISO cleanliness rating should be no higher than 18, 16, 13. This cleanliness rating refers to ISO particle count codes for the 4, 6, and 14 micron categories. If you are unfamiliar with ISO codes and cleanliness ratings, reach out to your Fluid Life representative for more information. Diesel fuel can oxidize when exposed to high temperatures and some contaminants for long periods of time, both in storage and in an equipment's fuel system. When fuel is degraded through oxidation, it is more prone to create oxidation byproducts like resins, deposits, etc. These byproducts do not burn with the fuel during combustion. Instead, they deposit and coat the inside of fuel lines, pumps, injectors, etc. They clog filters prematurely and interfere with the moving parts of low tolerance areas in the fuel system. In this sense, think of fuel like oil, different parts of crude oil distillate, but still susceptible to oxidation. Diesel fuel oxidation can also lead to discoloration. The fuel will usually get darker in color, turning to beige, to brown, and sometimes to black. The color does not necessarily correlate with the amount of oxidation that has occurred, but it is a good indicator that the fuel is degrading. Fuel oxidation, discoloration, and deposits are also known as asphaltene formation and/or coking. The most common causes of fuel oxidation and degradation are fuel temperature, water content, catalyzing metals, and storage time. Let's have a look at these in more detail. Out of the 4 reasons mentioned for fuel oxidation, elevated diesel fuel temperature is the most common cause. Earlier in the presentation, we stated that diesel fuel is the engine's power source and also acts as a lubricant. Well, diesel fuel also acts as a coolant. Diesel fuel is used as a coolant for high-pressure injector systems with high-temperature fuel-vetted walls. The fuel absorbs the heat, which introduces thermal stress to the fuel. Not all of the diesel fuel in circulation will pass through the injectors and be burned. A good portion of the fuel remains in high-pressure, high-temperature circulation. Continuous recirculation of thermally stressed fuel is a major cause of fuel oxidation and discoloration, especially if your fuel has poor thermal stability characteristics. Diesel fuel oxidation and thermal stability can be tested, and various OEMs have guidelines for this fuel characteristic. Some other potential root causes for diesel fuel thermal stress include lack of or faulty fuel coolers, improperly sized fuel tanks, inadequate mixing of return fuel, or lack of heat dissipation in fuel tanks. Most OEMs recommend a maximum fuel temperature of 70 degrees Celsius at the fuel pump inlet. The oxidization chemical reaction in diesel fuel will double with every increase of 10 Celsius beyond the supplier's recommended maximum. This is more important when dealing with biodiesels, who are more prone to oxidation when compared to crude oil distillate diesel fuels. Another cause of fuel oxidation is the presence of water. Emulsified and free water in a diesel fuel accelerate the natural oxidation process and promote the formation of byproducts, such as gums and resins. When formed, these byproducts are very likely to deposit on the fuel system components. Catalyzing metals can also lead to fuel oxidation. Some metals present in the fuel act as a catalyst to the oxidation process. Some of these metals include zinc, copper, lead, tin, etc. These metals typically come from the heat exchangers, tank corrosion, and other forms of external contamination. And finally, storage time. If temperature, water, and catalyzing metals aren't a problem, diesel fuel will react with oxygen and oxidize naturally over time while in storage. The longer a volume of diesel fuel is in storage, the more this process will occur naturally. Recommended storage times are typically based on the content of biodiesel in your diesel fuel blends. For B5 blends, which are no different than pure distillate diesel in terms of fuel characteristics, 1 year should be the intended maximum storage time. As biodiesel content increases, your storage time should decrease. For B20 blends, a 6-month storage time maximum should be applied. For B100 blends, pure biodiesel, a 3-month storage maximum should be applied. Storage time is something that your fuel supplier should be able to recommend. Consult with them to establish proper diesel fuel storage time maximums. Filter clogging will interrupt fuel flow. This can cause low fuel pressures and reduce fuel delivery, which will impact overall combustion efficiency and engine output. Fuel starvation from poor fuel flow can also lead to component wear through a process called cavitation. Proper fuel pressure must be maintained. OEMs will typically recommend that fuel pressure does not drop below 70 psi for most modern high-pressure fuel systems. Let's talk about some potential root causes for fuel filter clogging from diesel fuel issues. Wax deposits. When diesel fuels reach their cloud points in colder temperatures, wax crystals start to form, creating a gel in the diesel fuel. At high enough concentrations, this gel can easily and quickly clog a fuel filter. This is one of the main reasons for summer and winter diesel fuel blends, along with improving fuel flow in colder temperatures. Manufacturers will add pour point depressants, PPD additives, to reduce a fuel's cloud point. This issue is most common in late fall to early spring months, or when summer blend supply is used up as temperatures fall. Fuel clouding can start anywhere from -7 Celsius to -28 Celsius, depending on a fuel's PPD additive characteristics. Other sources of fuel clogging include solids and particulate. We talked about this already, but think about external ingression of contaminants, rust and corrosion, microbial growth, and breakdown of fuel system components as potential solids that can clog a filter. Oxidation byproducts, resins, deposits, etc., additives, any precipitates that originate from improper use of aftermarket additives, and biodiesel. This would come from the unreacted portion of original feedstock during the transesterification process. Another engine issue potentially related to diesel fuel is carbon deposits. Carbon deposit buildups are typically a byproduct of incomplete or inefficient combustion of a diesel fuel. The black soot-like deposits will harden on your engine components and can impact airflow and fuel delivery. Aside from maintenance practices and other engine mechanical issues, the most common sources of excessive engine carbon deposits are low-quality diesel fuels and high idling frequencies. Low-quality diesel fuels are more prone to incomplete combustion and can be saturated with unwanted contaminants that will deposit after combustion. Idling periods longer than 10 minutes on average can lower combustion chamber temperatures and increase the amount of incomplete combustion. Contamination mitigation and control strategies. There are many ways to control contamination, maintain fuel quality, and mitigate engine issues related to diesel fuel, both on the equipment side of things and also while in storage. It's important to understand that normal tank breathing and daily heating and cooling cycles can cause an accumulation of humidity and sediment in your equipment's fuel tank. Condensation of the humidity can lead to an accumulation of water at the bottom of the fuel tank, along with a buildup of sediment. Higher concentrations of water and/or sediment in the fuel tank can lead to the contaminants being drawn into the low-pressure side of the fuel system. This is why most OEMs will recommend draining sediment and water from your fuel tank on a daily basis, especially in areas of high humidity and great temperature variation. Your fuel tank vent and fuel cap configuration will heavily impact the size and concentration of sediment contaminating your fuel tanks. The use of fuel tank breather filters and unvented fuel caps can reduce the amount of sediment ingress while also extending the useful life of your fuel filters. Most OEMs will recommend that equipment fuel tanks be fitted with a tank vent filter of at least 10 microns to prevent dirt from entering the system as fuel levels drop from fuel consumption. While preventing contaminants from entering your system is an important part of fuel cleanliness, so is managing the contaminants once they're in there. Basic diesel fuel filtration configurations will typically include a primary diesel fuel filter, rated to 10 microns. This removes the largest debris that can cause the most damage to your fuel system components. If you are using series filtration, the primary filter also removes the largest debris that prevents the secondary filter, which is a lower rated micron filter, from clogging prematurely. Most diesel fuel filtration configurations will include some type of water separator as well. This doesn't remove all of the water from a fuel, but does a decent job at removing abundant free water present in a diesel fuel. Secondary filtration, or series filtration, has filters typically rated to 4 microns. Remember, 4 microns is the size of contaminants that most engine models are designed to function with. Secondary filtration is designed to reduce the overall amount of sediment that can cause damage to your fuel system components. While OEM fuel system filtration configuration and recommendations can be sufficient, it's important to ask yourself some questions to make sure that your equipment fuel filtration is optimized to your environment and PM schedules. Here are a couple questions to ask yourself to see if a change to your current filtration practices and configurations are necessary. Are your filters plugged before scheduled changes? Are you using the correct micron beta ratings? Are water separators filling prematurely? Are you utilizing series filtration? Up to this point, We've talked about preventing and removing contaminants from your diesel fuel while in use in your equipment. However, the best way to maintain diesel fuel cleanliness and quality is to manage contamination while in storage, before it even goes into your equipment at all. Contamination should be managed and prevented at every handling or dispensing point within your diesel fuel distribution system. Storage and handling for fuel bulk tanks. Storage time. While storage time is dependent on the fuel's biodiesel content, the longer a fuel is in storage, the higher the chance of it being contaminated. Tank breathing. The use of vent filters, preferably desiccant to absorb humidity, is heavily recommended to reduce the amount of humidity and sediment entering the fuel tank as fuel levels drop. Fuel level. It's a good practice to top off fixed roof diesel fuel bulk tanks as often as possible to reduce the amount of total tank breathing. Basic diesel fuel tank configuration includes a filtered vent cap to reduce contamination ingress during tank breathing, an unvented filler cap with a screen to prevent large debris from entering during tank fill-ups, a fuel filter right before the fuel goes out through the dispense line, and a drain valve to allow for the removal of water or sediment buildup at the bottom of the tank. Notice how the tank is on an angle to allow the maximum amount of water and sediment to be removed by the drain port. If you have more than one major distribution/handling location within your diesel fuel distribution network, it's recommended to have some sort of filtration process between these transfer points. A major distribution point is anywhere a fuel might be stored or handled in between fuel delivery to site and when it goes into your equipment. These filtration systems should include single or multiple stage filtration down to 4 microns, a water separator or coalescer capable of removing free water at a minimum, but ideally could remove emulsified water down to 0.01%. And inlet/outlet sampling valves to monitor fuel contamination levels before and after distribution point filtration. Distribution point filtration units exist in different configurations depending on your consumed volumes of diesel fuel and diesel fuel quality and cleanliness requirements. The image on the left is something you might find on a mine site, where diesel fuel distribution points are fixed and consumption rates are very high, compared to the image on the right, which is a mobile filtration unit that could be useful for smaller construction fleets that move from project to project on a regular basis. Filtration can also occur within a distribution point as well. This is called polishing, where diesel fuel is filtered while in bulk tank storage. This is common practice for larger tanks with lower consumption rates and/or tanks in unfavorable environmental conditions. Regardless of how many times your diesel fuel is transferred or handled, by the time it arrives to its final dispensing location and gets put into your equipment, it should be as clean and as dry as possible. Remember, maximum ISO cleanliness rating for a diesel fuel is 18, 16, 13, while maximum allowable water content is 0.05%. It's a good practice to take a diesel fuel sample from your final dispensing point on a routine basis to monitor the diesel fuel cleanliness levels of the fuel going into your equipment. Let's talk about a few general fuel dispensing guidelines to help prevent contamination. Number 1. Use a desiccant breather down to 4 microns for tank breathing within your dispensing unit if the system allows. Number 2. Cover, protect, and ensure cleanliness of all connection hoses, fitting, and dispensing nozzles. 3. If dispensing into a machine, keep the area around the machine fuel tank filler neck clean of debris to prevent dirt entry. 4. Finally, while dispensing, perform a visual inspection and take note of any potential sources of contamination. Don't forget about seasonal fuel changeovers in terms of creating potential fuel contaminants. Try to limit the amount of existing blend with new seasonal blend in bulk tanks, especially when transitioning from summer to winter blend. A significant volume of existing summer blend in a bulk tank that is filled with winter blend can create fuel gelling, clogged filters, and engine starvation. This is very common in the fall months when temperatures first start to drop, like October and November. Monitoring your diesel fuel. Just like oils, greases, coolants, etc., diesel fuels can be analyzed by a tribology lab for cleanliness and quality. Routine diesel fuel analysis will help you pinpoint sources of contamination and support contamination improvement efforts. The amount and type of testing completed should reflect what your goals are with the results and the issues that you are trying to identify. For example, minimum testing requirements include ISO cleanliness ratings and water concentrations, which are indicators of water and sediment buildup in your diesel fuel. This would be the minimum amount of correct testing to confirm excessive contamination of your diesel fuel while in use in your equipment, while more extensive diesel fuel testing packages include tests to monitor a fuel's coherence to ASTM D975 specifications. These options would be more useful if you wanted to confirm the quality of your diesel fuel for variables such as cetane index, flash point, etc. You can always contact your fluid life representative if you are unsure of what testing should be completed for any given situation. In terms of recommended diesel fuel sampling locations, these again should reflect your goals with the results and the issues you are trying to identify. Most common locations include the following: upon delivery acceptance, to confirm quality and cleanliness of the fuel received from your supplier; from bulk tanks, fuel islands, and dispensing points. Complete testing on 2 to 10 week intervals to monitor for contamination. Seasonal based testing recommended every 3 months as blends change. And from individual equipment tanks. Sampling from your equipment is typically done to support engine troubleshooting and investigate your diesel fuel as a potential source of an engine issue. Utilize standard diesel engine investigation charts and troubleshooting guides to determine if the fuel might be a problem. Request testing based on your initial observations and suspicions to confirm if your diesel fuel might be causing engine issues. Take a few seconds to look over the potential diesel fuel investigation pathways, depending on the engine issues you are experiencing over the next couple of slides. The recommended container for a diesel fuel sample is a 1-liter metal canister. Diesel fuel analysis requires more volume on average for testing compared to a typical oil sample. Also, the metal container will ensure that you don't run into any issues when shipping your samples to the lab, as diesel fuel is a regulated substance with strict shipping regulations. When sending in a diesel fuel sample for analysis, the results will only be as good as the sample being taken. It's important to take a good representative sample of your diesel fuel to have confidence in your results and any corrective actions taken after the fact. The most common sampling methods include the use of sampling valves, bacon bombs or fuel sample thieves, vampire pump and sampling tubing, and samples being taken from the drain pipe or plug. Sample valves can be installed anywhere where there is fuel flow. This is the best option as it ensures that samples are taken from the exact same location every time, reducing location variability in the results. They also keep the fuel system closed, and there is minimal sampling hardware or tools required to pull a sample. Note that fuel pressure is required to take a sample with a sample valve. Bacon bombs or fuel sample thieves are common for sampling bulk tanks without a sampling valve or any pressurized lines. To take a sample, you attach the bacon bomb to a rope or string and drop it into the bulk tank from a reservoir hatch at the top. When the bacon bomb touches the bottom of the tank, the tip pushes in, opening the bacon bomb and filling it with fuel. Samples taken from the bottom of tanks ensure that the most water and sediment are present in the sample. In smaller tanks, you can also use this tool to remove water from the bottom of the tank. Vampire, or vacuum pumps, and sampling tubing are ideal for sampling small bulk tanks or equipment fuel tanks. The pump creates suction to draw the fuel through the tubing and into the sample bottle that screws right onto the pump head. Because diesel fuel testing requires more volume than a typical oil sample, multiple samples may need to be drawn and potentially transferred over to a 1-liter metal container for shipping. The use of a standpipe is encouraged to ensure a known depth of diesel fuel sampling. What are your current practices to monitor diesel fuel cleanliness and quality? Are you taking any diesel fuel samples from bulk tanks or from storage on a regular basis? Do you know of and have identified your major fuel distribution points and potential sources of contamination at each location? Do you have any new or ongoing projects to prevent diesel fuel contamination and degradation? Have you ever audited your overall diesel fuel distribution network? These are all questions to ask yourself if you have the intention of improving diesel fuel quality and cleanliness for your operations. Assessing your diesel fuel network. A couple of main questions to consider. Do you know the quality and cleanliness of your diesel fuel when it arrives on site from delivery? How about after it's been handled or in storage for a while? Is it even clean when transferred to your fuel trucks and/or fuel islands? To properly start the audit process, you need to identify and understand all diesel fuel transfer areas, storage tanks, and dispensing locations. Samples should be taken from all of these locations to understand the current state and establish baselines. You need to know how things are and where the worst locations are before you can start to improve. Fuel analysis results will help you pinpoint the main sources of contamination within your diesel fuel network, along with the main type of contaminants, sediment, water, microbial growth, etc. Knowing this information will help you develop your improvement strategies accordingly. Water and solid contaminants are the most common diesel fuel issues and the easiest to improve on by considering the following: modifying storage time and volumes. This can reduce the amount of accumulation of contaminants and degradation of your diesel fuel before it's put into use. Implementing filtration and polishing units or skids. In situations where contamination might be inevitable, filtration and polishing in strategic locations can drastically improve the cleanliness of your fuel before usage. Modify PMs, hardware and equipment, and bulk tanks. Tank cleaning, fuel filters, tank draining, etc. Don't rely on filtration only. Try and prevent as much contamination as possible from all angles. You should also continue to monitor your diesel fuel after improvements have been made to ensure continued diesel fuel cleanliness. At this time, the frequency and locations of the samples can be reviewed and will likely differ from the initial auditing period. OEMs recommend diesel fuel analysis every 1 to 3 months from distribution points and directly from equipment when issues are suspected. Diesel fuel monitoring is something that we've helped our customers with before. One of our mining customers was failing injectors prior to engine midlife servicing around 10,000 hours on multiple dozers. Diesel fuel samples from the dozers showed elevated particle counts and no signs of free water. However, samples taken from the fuel trucks were much dirtier. The customer decided to improve fuel filtration on the fuel trucks and upgrade fuel filters on the dozer's fuel systems. While maintenance costs increased slightly, the customer has experienced no more premature injector failures since. Changes related to diesel fuel cleanliness improvements don't have to be major, expensive, or overwhelming. A couple main points to pull from this presentation. Even though fuel is consumed a lot quicker than lubricants, coolants, greases, etc., diesel fuel cleanliness and quality are very important for proper engine use. Most engine failures related to diesel fuel are due to contamination, mostly water and sediment. Diesel fuel can be analyzed in a lab for cleanliness and quality just like any oil sample. Routine analysis is recommended in some capacity. Improving diesel fuel cleanliness in any capacity can prevent failures of your equipment's fuel systems and prolong the life of your filters. If you require any diesel fuel analysis, please don't hesitate to contact us. Fluid Life provides an independent, OEM-agnostic evaluation of your diesel fuel samples and can help you maximize the value you get from your diesel fuel analysis. If you have any questions or would like more information, please contact us at 1-877-962-2400. Thank you.